Hello friends, a very good day to all of you. In this presentation, I will be discussing the various fundamentals and various types of form tools, platform and circular form tools, and its significance to metal cutting industries. If you see the texture of a complex job with cylindrical profile, and the machining of such a job is obvious. It can be done in a CNC machine. A program is necessary for a single point turning insert to feed along the geometry of that profile. That is the only one way we can look at, and it might seem that there is no other way. But there is also a method for machining such profiles, and the answer for such profiles are form tools. And what are these form tools? These are all customized inserts, and the cutting edge matches the intended profile of the part. As a result, a single straight plunge with the insert produces the desired shape. Now, Lucas, significance of form tool. When manufacturing the rotating parts such as shafts, axles and other, the total price of the product is strongly affected by the length of the parts manufacturing time as well as by the energy uses. If more than one tool is used for machining a single part, the total machining time for that part will be considerably longer compared to the situation when one complex geometry tool is used. A complex geometry tool on one hand can replace several tools, but at the same time it reduces the total machining time. The most significant reduction being that of idle times. Reduction of idle times means predominant reduction of tool change time. When machining of a product requires several different tools, it is not only that uses of several tools significantly extends machining time, but it is less cost effective. Taking into the account the fact that manufacturing of single part requires far more resources. Now, this will be illustrated in the video shown below. The video showed in the previous slides illustrate that the most important advantages of form tool is time. When the same turned profile is machined with a form tool against a series of single point tools, the simple in-out stroke of the form tool allows the profile to be machined in about 1/3 of the time. Given a large enough volume, this time saving can become attractive enough to justify the investment in customized tool. The second most, perhaps surprisingly, accuracy figures into the use of this tooling. A standard single point turning tool following an interpolated path involves two machine axes, where a form tool uses only one machine axis. So with fewer moving elements to contribute to process error, the form tool can often make it easier to consistently achieve tight precision. Third, inevitably the finish which is achieved with the help of form tool is of greater advantage, because when a single point tool, as it moves, it forms the cusps between rotations of the workpiece as the cutting point travel along the contour, and this offers to the surface finish the peaks and valleys. But in a form tool, it completely omits these cuts, because the entire segment of the part represented by the form is machined in a single plunge. One more additional factor is tool life. Now for a single point cutting tool or insert, the tool moves along the profiled segment of the part. Therefore, all the energy of the cut contribute to tool wear is concentrated into that single point of contact between the tool and the part. In contrast, the form tool cuts along a line of contact, thereby with the energy of the cut distributed along the profile. As a result, a form tool can be counted onto wear much more slowly, not only reducing the rate at which new inserts need to be purchased, but also reducing the amount of time that is lost to tool replacement. Owing to the growing popularity of form tools, which can be attributed to minimized manufacturing costs and shorten the manufacturing time, but on the flipper side, one of the major drawbacks or disadvantage is the method of the design. It reflects in the constraints present in the machining of straight line and circular arc segments of the workpiece as shown in the figure. For each segment, the rake angle has a different value, which then imposes an additional constraint. Now, if the component has to be machined in a single point cutting tool, then we can use multiple single point tools with different rake angle, and that can be achieved. In case it is necessary to use form tools to manufacture complex geometry parts as shown in this figure, then the value of the rake angle would require to be 0. More than the rake angle, the clearance angle provided to these form tools will be of significantly important. We will be doing various numericals on both flat form and circular form of tools having clearance angle alpha, and not only having 0 rake angle, there will be designs where the rake angles can be made positive or negative. Thereby, finally we can find out the depth of the form tool, which is measured normal to the front clearance phase, which you will find is less than the actual depth. As we know, the form tools, they are increasingly implemented in industry, whether it is a prismatic or a circular form tools. The conventional design method of form tools has placed constraints on their implementation. On one hand, constraints occurs in the form of the workpiece geometry that can be built, whereas another constraint characteristics is varying rake angle as a function of the workpiece segment diameter on the other hand. Classification of form tool. Now this classification is displayed in a form of tree diagram. The form tools are basically classified in three categories. One, according to the cross section, that is, they may be flat or circular or end form. And the flat tools are basically classified according to the setting of cutting edge. That means it can be radial or tangential. And for circular form tool, it is classified based on the orientation of tool axis. That means it could be parallel or angular. And the end form are generally used to form a shape at the end of the tubes or board component. Now, according to the setting of the cutting edge, they are classified as either radial feed or tangential feed, as shown in the figure. This slide shows a circular form tool. At the left hand corner, the slide shows the machining of the grooves cut with the help of the circular tools. And the circular form tools are attached to the slides of the lathe machine, which has a circular shape, and it has a depth X or a projection X produced all around the diameter in the form of annular grooves. The outside diameter of circular form tool is determined in accordance with the height of the profile to be turned. This slide shows a straight form tool, and it is also called flat form tools, generally having a square or a rectangular cross section and with the form being at the end of the tool's end, and which apparently looks like a turning tool. These are usually set centrally so that they cut the profile which is identical to the desired contour of the workpiece. A typical example is a V-notch tool or a threading tool, and this type of tool is suitable for making deep straight-sided form grooves, and the cutting is restricted due to the mixed chip flow. Because of the good surface finish they produced, typically these tools are operated at a very low cutting speed.